Hi all, welcome to ANIL NAIR classes YouTube channel. What is that we have discussed? Base system is a system which is used to represent a numerical value, with selected few digits. If you are able to represent a numerical value, that is called a base system. In that base system, there are four major base systems. One is a binary system, another is an decimal system, another is octal system, another is hexadecimal system. These are the four basic systems which are present. We have seen all these types in our class. What are the types that we have seen? Binary will have 2 digits, which is 0 and 1. Decimal will have 10 digits, which is 0 to 9. Octal will have 8 digits, which is from 0 to 7. And hexadecimal will have 0 to 9 numerical values A, B, C, D, E, F, which will have total 10 numericals and 6 alphabets. Now, what are the concepts that we discussed? These are the concepts we discussed yesterday. How to convert from non-decimal to decimal. How to convert from decimal to non-decimal. How to convert from non-decimal to decimal. How to convert from k power x to k power n. X is greater than n concept. How to convert k power x to k power n, x is less than n. How to find out a particular base. How to add two numbers in a non-decimal system. How to check whether the answer is right or wrong by using digital sum concept. How to add two numbers in to non-decimal system. How to subtract two numbers in a non-decimal system. All these concepts we have discussed yesterday in session 1 and session 2. Session 1 and session 2, which we have discussed. Today morning, we have discussed till here. We have discussed in the morning 7 o'clock session how to divide two numbers in a non-decimal system, how to multiply two numbers, how to check whether a non-decimal number is an even number or an odd number. Divisibility rules, we have solved good number of problems. So we are here. Good number of problems. Now we will try to complete this and this. If possible, few advanced level questions. These three concepts which we are going to solve it. Now, just let me do a recap in case if any student is listening to it for the first time. With all due liking towards you, when you are enjoying, your friends are watching the class and improving their skill set. Now the choice is with you to probably not to miss any classes in future and or probably go through some entertainment videos in YouTube, right? Waiting for things to happen anyway that you are there in the wrong path. I don't need to tell you, you yourself will know it. Conversion from non-decimal to decimal, one example. Non-decimal to non-decimal, second example. Decimal to non-decimal, 2 examples. Conversion from non-decimal to non-decimal, 2 examples. Conversion from k power x to k power n, 2 example. X greater than n, x less than n. Conversion from finding the base, close to 6 to 7 examples. This question which we have not discussed, I will discuss this question right now once I complete a concept. Right? How to find whether it is a perfect square. Addition of two numbers, 3 examples. 4 examples. Subtraction of two numbers, 4 examples. Division of numbers, 4 examples. Product of numbers, 3 examples. How to check whether a number is an even number and an odd number, 3 examples. 3 plus 4, 7 examples. Divisibility rule. Morning we discussed all this. right? Now here also we discussed, we are actually here. We are actually here. I will just repeat this concept then and everything. Base system reminders concept 13. Morning we wrote it, I will repeat it again. In a base system K, if I take a base system K, divisibility rule for K plus 1, is nothing but sum of the odd places minus sum of the even places should be either 0 or it should be divisible by K plus 1. This is the concept. Morning we wrote it. Now we will take an example and we will do it. This is the concept. Morning we wrote it. Now we will take an example and we will do it one by one. First one, see this question. Now another concept also which we discussed, it is not only for the divisibility rule for K plus 1, this also holds good for all the factors of K plus 1. All the factors of K plus 1. That means for example, if this question is there, 2, 1, if you see this question, 2, 1, 3, 4, 7, 2, 1, 3, 4, 7, 6, 4, 8, in base system 9, it is divisible by 5 in base system 9. Find the remainder in the following. So if you see, if I take this example, this is in base system 9, K is 9. If K is 9, what is the divisibility rule for 9 plus 1? 10. What is that? Sum of odd places minus sum of even places. It is not only for K plus 1, it is also for factor of K plus 1. It is also for factor of K plus 1. Factor of K plus 1. What are the factors of 10? Factors of 10 are 1, 2, 5, 10. What is the question given? 5. So I can use this logic. How to use the logic? Start from the rightmost. Odd places alternatively keep plus minus, plus minus, plus minus. That is how we do sum of odd places minus sum of even places. 8 minus 4 is 4. 6 minus 7 is minus 1. 4 minus 3 is plus 1. 1 minus 2 is minus 1. Minus 1 is minus 2. 4 plus 1 is 5. 5 minus 2 is 3. 3 divided by 5. Answer is 3. First one, answer is 3. Again I am explaining. The root cause, you will think that this question is a difficult question because maybe you do not know the concept behind the question. First thing, it is in base system 9. In a base system 9, divisibility rule for 9 plus 1, 10 is. Divisibility rule for 10 in a base system 9 is sum of odd places minus sum of even places. Start from rightmost. Alternatively keep plus minus, plus minus, plus minus. So 8 minus 4 is 4. 6 minus 7 is minus 1. 4 minus 3 is 1. 1 minus 2 is minus 1. Minus 1 minus 1 minus 2. 4 plus 1 5. 5 minus 2 is 3. Over answer. Easily you can solve. Suppose second question. What is the question? Find the remainder of 3 1 4 1 5 9 2 6 5 3 in base system 7. It is divided by 4 in base system 7. Just now we discussed in a base system 7. In a base system 7, what is the divisibility rule for 7 plus 1? 8. Divisibility rule for 8 are factors of 8. Are factors of 8. What is the rule? Sum of odd places. Morning I discussed the proof. Sum of odd places minus sum of even places should be either 0 or it should be divisible by 8. Is 4 a factor of 8? Yes. So alternatively plus minus, alternatively plus minus, alternatively plus minus, alternatively plus minus. So 3 minus 5 minus 2, 6 minus 2 plus 4, 9 minus 5 plus 4, 1 minus 4 minus 3, 1 minus 3 minus 2 divided by 4, minus 2 minus 3 minus 5, 8 minus 5, 3, 3 minus 2, 1, 1 divided by 4 is 1, 1 divided by 4 is 1. I hope it is clear. This idea, even the third problem idea is also similar. In a base system K, the divisibility rule for K plus 1 is sum of odd digits minus sum of even digits. It should be divisible by either K plus 1 into something or the difference should be 0. Third one, I am directly writing the third one. Why? Because it is in 8. 8 means for 9. R factors of 9. R factor of 9. Use the rule. Sum of odd places. Sum of odd places minus sum of even places. So this will be plus minus, plus minus, plus minus, plus minus, plus minus, plus. 4. 5 minus 1 is 4. 6 minus 7 is minus 1. 3 minus 2 is plus 1. 2 minus 2 is cancel. 1 minus 3 is minus 2. 4 plus 4, 8. 8 minus 2, 6. 6 divided by 3 is 3 ones are 3. Remainder is 3. I hope the idea is clear. I hope the idea is clear. Concept 13. Concept 13 is nothing but finding out the divisibility rule. Finding out the divisibility rule for K plus 1 or factors of K plus 1 or factors of K plus 1 in a base system K. In a base system K. In a base system K. How to do this? Divisibility rule for K plus 1 or the factors of K plus 1 in a base system K. What is concept 12? Concept 12 is in a base system K. In a base system K, finding the divisibility rule for finding the divisibility rule for K minus 1 or factors of K minus 1 or factors of K minus 1. What is the concept? It is a digital sum. It is a digital sum. 9. K minus 1 is 8. 4 is a factor of 8. Digital sum. 7. K minus 1 is 6. 3 is a factor of 6. 11. K minus 1 is 10. 5 is a factor of 10. Concept 12 over. Concept 13 over. I hope it is clear. Now,
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.